Let's do it. Today, we will be solving radical equations. All right. So before we get into the lesson, let's go over some things that we should know. All right. First off, whenever you see a f with the x in parentheses, this means a function of x. Okay. Now, when you see that f of x with a -1 as the exponent, we're talking about the inverse. All right. We're talking about inverse. So, all right. Inverse is defined as a process that undoes another process. All right. Some people say reverses it, but we'll define it as a process that undo another process. All right. And I like to use this symbol here. I do an arrow going up and arrow going down. So I like to use that. All right. So, for instance, the inverse of addition is subtraction, right? The inverse of multiplication is what? Division. So addition undoes subtraction and multiplication undoes division. Okay, so we'll use this symbol. Anyway, so just starting off, you need to know that the square root of something can be undone. All right. The inverse, put my little made up symbol here. The inverse of a square root, we'll take that same letter, is squared. Okay. Let me show you again. Try this. The inverse of a cube root is x cubed. What did I do? I took the index, and whatever the index is, that will undo the radical. If you use the index as the exponent, that will undo the radical. So whatever your index is, if you use that as your exponent, it will undo the radical. Let's go into detail. All right, let's do it. Okay, so let's say you have a problem, and it says, well, you got x equal, let's say 3. And your goal is to get x by itself. Well, to get x by itself, you have to remove the what? The radical. And no, you can't. You cannot just delete it. Gone. No, you cannot do that. That will not work. So in order to get x by itself, you must undo the radical. You undo the radical by raising both sides of the equation to the index. So if that's a square root, I square the whole problem, the whole radical. I say that, the whole radical. Whatever you do to one side of the equation, you do what? to the other side. Then what happens is the radical and the index, the index and the exponent will cancel out, leaving x by itself equals to 3 to the second power, which is 3 times 3. That means x equals 9. All right? Let's do it over here. So if you got a problem, and this is what will happen, you'll get the problem all the way to the end. Let me fix that. You'll do the problem, get all the way to the end, where you will have the radical and everything, radical on one side of the equation, and your everything else on the other side. And you'll be faced with this decision. This is going to happen. You have to get x by itself by removing the radical. Well, the only way you can undo the inverse of a cube root is what? Cube, right? So you cube it, and whatever you do to one side, you do to the other side, right? That way, the index and the exponent cancels out. X is left over, and you're left with 2 to the third power, which is 8. You better not say 6. All right. So when we get to the end of the problem, the last thing almost the last thing you'll do is to get the x by itself. And you do so by removing the radical. Using the inverse, right? All right. Let's start it off. Wait. There's one more definition we need to know. Okay. There's a term called extraneous. Extraneous means outside of the solution. For instance, let's say you need a kitchen table. You just got your apartment, new apartment, you need a kitchen table. And you go to the furniture store, or a furniture store, and the salesman says, hey, we have a great kitchen table for you. Here it is here. You love it. When you look at the price tag was $20,000. See, that table is going to be extraneous. It's going to be outside of the solution. Because I don't know where you can go to borrow $19,500. And if you do know somebody, get me a few thousands as well. You pay it back. But extraneous. These are, we'll put results. Results that are outside of the solution. All right. So let's go ahead and get started. Now, step one. Step one is going to be to isolate the radical. Isolate the radical. And identify the index. All right. After you get the radical by itself, find out what you're working with. Identify the index. All right. Now, step two is going to be to remove the radical. Remove the radical. by raising each side to the power of the index. All right. Step 3 is to solve the remaining equation. Yeah, going back to unit 1. All right. And the last step that my students absolutely hate to do, get problems wrong just because of this, is you need to check for extraneous solutions. Because just because you get a result, just because you get an answer, does not make it the answer to the problem. Yeah, I know. But now it is imperative that you check. All right, here we go. Let's start with a pretty good easy one. Let's make sure we can see these rules. All right, here we go. Let's try it. Our first example is square root of x equal 9. All right. The first rule says isolate the radical. Well, what's the good news? The radical is already on a side of the equal sign by itself. Now, what's the index of that radical we have over here by itself? Uh-oh. What's the index in there? It's blank, so it's a 2, right? So we need to remove the radical by raising each side to the power of the index. So we need to remove this radical by raising, let's change that color. By raising both sides to the power of the index. That makes the radical cancel out. Now we're left with x is equal to -9 to the second power. You better not say 18. All right. We're saying the answer is 81. All right. So there's no need to do step 3 because x is already by itself. It's already solved. But we have to check for step 4. All right. So here we go. Let's do all that. So in the original problem, we had square root of x. It says x is 81. So the square root of 81 is supposed to equal 9. Well, let's break down 81. 81 is 9 times 9. Well, we can stop. We needed 2 or something. We got it. So the 9 comes out. Nothing left in. So yes, 9 does equal 9. So it is not extraneous. This is the solution. All right, let's keep it going. All right. Take a couple of these to get the feel for it. Let's see. We have 6 is equal to the square root of 4y. All right. It says isolate the radical. Well, the radical is already on the side by itself. Identify the index. The index is 2. So remove the radical by raising each side to the power of the index. Cool. So we're going to remove the radical by raising each side to the power of the index. We're left with 6 to the second power equals, the radical index will cancel out, so we get 4y. All right. Now, how do we get Y, all right, we're not done. All right. Because you can't get y by itself until you finish this 6 squared. Let's go ahead and get that going. All right. So 6 squared is 36. 36 equal to 4y. All right. Now, it says solve the remaining equation. If we had to get y by itself, we had to remove the 4. How you remove a coefficient? Unit 1, by dividing both sides by that coefficient. The 4's cancel. 36 divided by 4 is how much? 9. 9 is equal to y. Now we're going to check for if the solution is extraneous or not. Here we go. So we had 6 is equal to the square root of 4 times what we say y is? 9. All right. So we'll bring the 6 down equals the square root. 4 times 9 is what? 36. All right. Let's break down that 36 to see what's going on with it. 36 is 6 times 6. I don't have to go any further. I see I got 2 things, so the 2 things will come out, and 6 does equal 6. So this is also not extraneous. These are, so this is a solution in my budget. All right. All right, let's keep it going. Let's try this one. Square root of m plus 5 equal 2. All right. That's still not too bad. All right, so it says step 1. We hadn't had to do a step 1 yet, but we're getting there. So it says isolate the radical is already isolated. Once it's isolated, identify the index. This is also an index of 2. So we will raise both sides to the exponent of 2. The 2's and the 2 here and the index here cancel out, and you're left with m plus 5 equals 2 to the second power. All right, we're not done because we got to take out m to the second power, which is m plus 5 is equal to 4. All right, now solve step 3. Solve the remaining equation. How do you get m by itself? By moving the 5. That's a positive 5. We subtract 5 on both sides. See there? Coming back to unit 1. I tried to show you. Come on now. M, the 5's cancel, equal to 4 plus negative 5 is negative 1. All right. Now we have to check for extraneous solution. Let's see if it's extraneous or not. Our original problem said the square root m is negative 1 plus 5. And we say it's going to equal 2. All right. So negative 1 plus 5, that's the square root of 4 equals 2. And the 4's, when you break it down, you get 2 times 2. That's 2 2s. So 2 comes out. 2 comes out, right? And nothing left over. So 2 is equal to 2. So again, this is not an extraneous result. All right, let's keep going. Let's see. All right, let's pick it up a little bit. That was 3. Get us good and started off. All right, so here we go. If we have a problem that says 2 square root of k minus 4. When you're writing, be careful. Make sure everything that's supposed to be under the radical is under the radical. And everything that's not is not. And equals negative 3. Don't roll your eyes now. You knew this was coming. All right. So rule 1. Step 1, it says isolate the radical. Let's start there. You're trying to get the square root of k minus 4 by itself. In order to do that, you must remove everything else. And you do the same thing we talked about. Constant terms are moved first. Remember? Constant terms are moved first. So if that's a negative 11, we're going to add 11 to both sides. All right, we'll bring all this down. 2 square root of k minus 4. 11's cancel out is equal to 8. All right. Now, we still got to get k minus 4 by itself. And coefficients, you divide those last, right? So the coefficient we have to divide by is that 2, because we're trying to get that, k, the square root of k minus 4 by itself. Divide both sides by 2. The 2's cancel. Now, k minus 4 is left over, equals 4. All right. Now, we have the radical by itself. Now it says identify our index. It's still 2. So, hey, it says remove the radical by raising both sides to the index. All right. Index and radical cancel out. We are left with k minus 4. See, no more radical. Equals 4 squared, which is k minus 4 equals, you better not say 8, 16. And how do we get k by itself? We solve the remaining equation, right? That's rule 3. Rule 3 is right here. Once you get the radical by itself, we want to rule 3. All right. So to get k by itself, remove that constant term. Add 4 to both sides. And we are left with k, the 4's cancel, is equal to 20. All right. Let's see if 20 is an extraneous solution. All right. So our original equation, our radical equation, oh man, I'm running out of room, is, not if I do like this, okay, is 2 square root, we said k was 20, 20 minus 4 minus 11, minus 11 equals negative 3. The only thing I did was go back to my original problem and plug in, we said it was 20, so I plugged it in where the variable was. All right. 20 minus 4 under the radical is 16. Oh, it's going to work out. 16, square root of 16, bring the 2, bring the minus 11, equals negative 3. Bringing all that down. And remember, if you're trying to simplify, you got to take care of the radical first. You got to simplify the radical first. Find out if we can get anything to come out. So 16 is 4 times 4. I got 2 4s. Now, if you would did 2 and 8 and kept going, you still would have pulled out a 4. So a 4 is going to come out with that 2. And we're left with 8 minus 11, right? We're not minus 11 equals negative 3. What's 8 minus 11? Negative 3. So negative 3 does, in fact, equal negative 3. So 20 is not extraneous. All right.